In this section, we're going to continue what we did off in the previous section, but we're going to introduce another way to solve those systems of equations that we had. And it's going to be through something called a matrix. So for example, in the previous section, we solved a problem that maybe looked like this. We had 7x minus y is equal to 11, and then maybe 6x plus 2y is equal to 13. So an equation is something of this form. So this is called a system of equations. Now we can turn this into a, so just for reference, we'll call this is a system of equations. But we could turn this into a matrix. And so what a matrix is, we're going to draw some parentheses. And whenever, so you see here we have an x and a y. So there's going to be a column for some x's, a column for some y's. And this equal sign we usually represent as a vertical line. And then over here, we're going to have, I guess, what we can call the answers. And so in these little sections over here, in this top row, we're going to put the number in front of the x, the number in front of the y, and the answer. So the number in front of the x is a 7. The number in front of the y is a -1. And the answer is 11. Now for this one, the number in front of the x is a 6. The number in front of the y is a 2. And the answer is 13. And this right here is called a matrix. And so this is how we can go back and forth. If we have the system of equations, we can write it as a matrix, and it looks just like this. And now why a matrix is nice is, for this example, it's not necessarily easier or harder to do a matrix to solve this problem. In the previous section, we saw we can do either substitution or elimination to solve equations that look like this. But where the matrix is going to be a lot more helpful is, say if we have a system of equations that has 3 variables, so maybe x plus y plus z is equal to 11, 11x plus 0y plus z is equal to 2, and then maybe to something even like 0x plus 11y plus z is equal to 13. So if we're going to turn this into a we could also, let's just talk about the ways we could solve this that we already know of. So we're not going to be able to use substitution to solve these, but we could use elimination, but it's going to take a good amount of time, and there's a good chance getting lost along the way. But if we turn this into a matrix, so this is going to be 1, 1, 1, 11, 11, 0, 1, 2, 0, 11, 1, 13. So again, here's the 1x, 1y, 1z, 11, 11x, 0y, z is 2, 0x, 11y, 1, 13. So we're going to see in this section that solving a system like this with 3 variables is much easier to do when we have a matrix. And that's because when we have a matrix, there's going to be, in this next page, we'll talk about, there's going to be a sequence of steps that we'll follow, sort of just like a pattern, and we keep repeating that pattern until we get to the answer. It may be time consuming, but it's at least there is a pattern to follow, so you won't get lost along the way. So on the next page, let's do an example, just how we can solve one like this. So the example we're going to solve, 4x plus 8y minus 4z is equal to 4. 3x plus 8y plus 5z is equal to minus 11. Then minus 2x plus y plus 12z is equal to minus 17. And so also this same problem is on the notes online. I just thought I'd do it so we can kind of go through each step. I don't have the notes in front of me, so maybe we'll do a little bit different steps here, but we'll get to hopefully get to the same answer. Anyway, so like we said in the previous section, we can use elimination, meaning we can figure out ways to eliminate stuff, to solve for variables, plug things in. But with 3 equations, that becomes really hard, and it's really easy to get lost. So to do this, we're going to turn this into a matrix, then we'll go through how does turning into a matrix even help us. So let's call it, we have 4, 8, minus 4, 4, 3, 8, 5, minus 11, 2, 1, 12, minus 17. Okay, so our goal let's just write this on a different page. And we'll come back to this. So our goal is when we have our matrix, we want the matrix to eventually look something like this. Line. And then over here, we'll have some numbers we'll call A, B, and C. So what does this mean? Remember that this is the number in front of the X, this is the number in front of the Y, this is the number in front of the Z, this is the answer. So that means we're gonna have a 1 in front of our X, a 0Y and a 0Z, so nothing, equals A. Here we're gonna have a 0 in front of our X, a 1 in front of our Y, a 0 in front of the Z, so the X and the Z go away, equals B. Here we're gonna have a 0 in front of the X, a 0 in front of the Y, but then a 1 in front of our Z. And so that's our answer, C. So if we could turn our matrix, the left-hand side somehow, if we can manipulate it to look like this, then these are all of our answers right here. And now let's go back to the problem that we have. See our problem here, now we have all these numbers over here, but somehow we can manipulate it, you know, to look like this. So we can get a 1 here, 0, everything beneath of it, a 1 here, 0 and a 0, and a 1 here and a 0 and a 0. Those numbers over here, after we're done all that, will be our X, our Y, and our Z. And so let's talk about what are we allowed to do in order to do that. So the sequence of steps is the first thing we want to do. Let's just turn this top left number into a 1. And there's going to be several ways that we can do that. So what we can do, these, and this for names, these things that go sideways, these are called rows. So, you know, here's row 1, here's row 2, here's row 3. So we're allowed to add rows together, meaning we can like make a new row by adding row 1 and row 2. So for example, you'd have like 4 plus 3 is 7, 8 plus 8 is 16, minus 4 plus 5 is 1. That's fine. So we can add rows together in order to try to make this a 1, and also subtract. So you see, if we subtracted row 1 and row 2, we'd have 4 minus 3, which is 1, 8 minus 8 is 0, and so on. Or we can also divide a row by a number. So we could decide to divide this whole row by 4. So let's do that method. Let's divide this whole top row by 4 and make a new matrix. So we're going to take our old row 1, divide it by 4, but we're not going to change row 2 and we're not going to change row 3. So let's see what happens. So we divide this one, because remember our goal was to make this a 4, or sorry, to make this top left thing a 1. And if we divide this whole thing by 4, there will be a 1 there. So you see now we're going to have a 1, and then we'll have a 2, that'd be a minus 1, and that'd be a 1. Here we still have our 3, our 8, our 5, and our minus 11, and then minus 2, 1, 12, minus 17. Okay, so that's always the first step. The first step is always make the top left thing a 1, which we did. Now our second step is going to be to make the things beneath of this thing a 0. So make this a 0 and make this a 0. Okay, and now, but that's going to be easy to do because we have a 1 right here. Meaning what we can do is let's not change row 1. So this row 1 now is this row 1. But to make this a 0, we can do this minus 3 of that. So row 2 minus 3 of row 1. And then for this one right here, we can do row 3 plus 2 of row 1. So let's just rewrite this row down and explain what we're doing. 1, 2, minus 1, 1. See what happens now when we do row 2 minus 3 row 1. Row 2, which is 3, now minus 3 of this. That's 3 minus 3, which is 0. Now row 2, 8 minus 3 of that. So 8 minus 3 of that, which is 8 minus 6, that's 2. Now 5 minus 3 of this, well, that's 5 minus a negative 3. So 5 plus 3, which is 8. And a minus 11 minus 3 of that, that's going to be minus 14. And now we'll do that same thing for the next one. Row 3 plus 2 row 1. This plus 2 of that, 2 of 1 is 0. This plus 2 of that, that's 5. 12 plus 2 times minus 1, so 12 plus minus 2, which is 10. Minus 17 plus 2 of this, that's minus 15. Okay? So we've completed our first 2 steps. We were given this. We said our first step was turn the top left thing into a 1, and we did that here. Our next step was to make everything beneath of that a 0, and then we do that here. So now our next step is we want to, so you remember we made the top left thing a 1. Our next step is to move down the diagonal, and now we want to make this a 1, this 2. So let's not change row 1. We can easily make this a 2 by dividing by 2. So let's do that. Let's do row 2 divided by 2, and let's keep our row 3 the same. So we have 1, 2, minus 1, 1. Here we're going to have 0. This divided by 2 is 1. This divided by 2 is 4. This divided by 2 is minus 7. And then copy that row the same. Okay, so that was our third step. First step, make this a 1. Second step, everything is 0. Third step, move down the diagonal, make this a 1. And now repeating the pattern, we want to make everything beneath this one a 0. So let's make this a 0 now. So let's leave our row 1 and row 2 the same. In order to make this a 0, we can subtract 5 of this from it. So we're going to do row 3 minus 5 row 1. Okay, so we're going to have 1, 2, minus 1, 0, 1, 4, minus 7. Now this minus 5 of that, 0. This minus 5 of that, 0. This minus 5 of that, so 10 minus 20, which is minus 10. Okay, now minus 15 minus 5 of that, so minus 15 minus a negative 35, which is minus 15 plus 35, which is 20. Okay. And then we completed that step now. So you remember we made this a 1, everything beneath of it is 0. Now, remember how we kept moving down the diagonal? So we're going to move down the diagonal one more time. So now we're going to make this a 1. So that's going to be easy to do. We'll keep row 1 the same, row 2 the same, and just divide this whole row by negative 10. And so what do we get? We have 1, 2, minus 1, 1, 0, 1, 4, minus 7, 0, 0, and then divide that by minus 10, divide that by minus 10. Okay? See, now we're almost done. Remember, our whole goal was to do this shape on the left-hand side. The 1s and 0s everywhere else. We almost have that. Now we have 0s down here, 1s here. We got to make these are 0. And so now we're going to repeat the same steps we just did, but backwards. So what we're going to do now is start down here, make everything above it as a 0. So what we can do, we take row 1, add it to this, we'd have minus 1 plus 1, which is 0. So this new row 1, let's do row 1 plus row 3. For this one, we have to do this minus 4 of that. So row 2 minus 4, row 3. And let's keep row 3 the same. Okay, so what are we doing? Row 1 plus row 3. 1 plus 0, 1. 2 plus 0, 2. Minus 1 plus 1, 0. 1 plus minus 2, minus 1. Okay, row 2 minus 4, row 3. That minus 4 of that, 0. 1 minus 4 of that, 1. 4 minus 4, 0. Now minus 7 minus a minus 8. So minus 7 plus 8, which is 1. And row 3 the same. 0, 0, 1, minus 2. Okay, now we're almost done. The last thing we want to do now is move up. So remember we had the 1, make everything above it a 0. Now here's our 1. Everything's above it a 0. Move back up the diagonal, make everything above this a 0. So let's make this a 0. And that's easy. All we have to do is just take this and subtract 2 of this one from it. So row 1 minus 2 row 2. Row 2 is the same, row 3 is the same. So 1 minus 2 row 2, that's again still 1. 2 minus 2 is 0. 0 minus 2 of that, so 0 minus 0 is again 0. Now minus 1 minus 2 of that, that's minus 3. Now everything else is the same. 0, 1, 0. 0, 0, 1. Minus 2 and 1. Okay, so this tells us that our x is minus 3. Our y is 1, our z is minus 2. And this will be the answer for this problem. And a way you could check to see if this is correct, We don't really have much room on this paper. If we needed to check, so we could plug these numbers in here to make sure. So for example, let's do this first one. Maybe we could squeeze it down here. So if x is -3, so we're gonna have 4 times -3, that's -12. Y is 1, so then +8. Z is -2, so that's gonna be +8 again. So what does that equal? So we're gonna have 16 -12. 16 -12, which is 4. All right, and so that's what it needed to equal. 16 -12 is 4, and so that's correct. So if we plugged in x, y, and z here, we need to get 4. And you see, if we did the same thing for all these other ones, if we plugged our x, y, and our z in here, we would need to get -11, and if we plugged our x, y, and our z in this one, we would need to get -17. So that's a way you could check your answer. Yeah, so for this answer, or for this problem, this is going to be our answer.